Hi, this is part 2 of the CNC CAM tutorial. In this tutorial I'll be explaining how to cam parts that won't use tabs. This way you don't have to mallet them out and sand them down before we powder coat them. Alright, so as you can see here, I've made a few adjustments to the plate that we had earlier. Over here I added some countersinks and I changed the pocketing just a bit. Otherwise everything's going to remain the same. The first steps are going to remain the same as camming with tabs, in the sense that we're going to be creating the same assembly. So I can just go here, Control C, Control V, do that twice. And now all we have to do is constrain them so they're on the same plane. Let's change this up so we can't see the planes. So View, Object Visibility, go down to User Work Planes. And let's change the visual style to shaded with edges. Alright, a bit easier to see. So now we have to put them on the same plane. So we're going to constrain their top faces and set them to be flush with each other, like this. Okay, now as you can see, if I take a side view of this, these are perfectly in line with each other. Now it's up to me to figure out what is the best configuration for them in order to save the most amount of material. For now, I'll just do it something like this. Let's offset them 0.5 away from each other, and we should be good to go. Alright, let's get to camming. So we're going to go to cam, and the first thing we're going to do is do a setup. Right, just like before. Pick one of your stock points. It's always going to be one of the bottom dots, so out of these three, I'm going to pick the bottom. And as you can see here, it is already the way I want it, with the Y direction here, the Z up, and the X like this. So it's going to CNC the material in this direction, with the Y this way, X this way. So this would be like an overhead view of the CNC. Alright, that looks good to me. Go to the stock. It's important when you select your stock that you start in the bottom face. Here I can show you that when you select the top face instead, you can see how it shifts the stock point to the top, and that's kind of annoying. So instead, oh great. Let's reconstrain this and go through that process one more time. Even though I constrain this, it still has the ability to move like this. So I'm going to line it the way I would like, and then I'm just going to ground these two. So grounded, say grounded one more time, and now these two can't move. Let's go to cam and do that process again. Setup, pick your stock point, X, Y, Z, all the way I like it. Stock, start on the bottom, and then do the top. Now you can see that my X, Y, and Z is shifted here. So I'm going to go back to the first tab and then reselect that dot. Alright, go to the second tab. Everything looks good to me. One thing you do want to check is that the height over here is the thickness of a material, which happens to be 0.25. If it's not the thickness of a material, you know you screwed up somewhere. So you're just going to hit OK. Alright, so now we've done the setup. The first thing we want to do is our drill function. So we are using a 3/16 bit, which goes for number 10 bolts, so we can drill out all of our number 10 bolting holes. So that'd be like here, here, here. And then do the same thing on the other plate. Alright, so now we've selected all the bolt holes. Now we're going to go to this part over here, our tool. Select the tool we're going to use. My libraries. It's going to be the 3/16 one. Alright, my numbers, I'm going to turn these are the default numbers. I'm going to turn it down to 12 inches per minute just to be safe. And all the other numbers are fine. Second tab, that looks good. over here, this is where stuff starts getting different than camming with tabs. So typically we're going to do bottom height, whole bottom, right? Stock bottom. And that's right. And all of these ones, just like the tabs, we're going to leave alone. But you'll notice once we get into the pockets and stuff, we get to start messing around with these numbers. Otherwise, these numbers can just remain 0.4, 0.2, 0.2, and 0. Alright. Now, the first part that differentiates this from camming with tabs is that we're going to stop here and we're going to post-process it just the way it is. So we post-process it, don't mess with anything here, just press post, put it into the USB, and let the G code just download. Now, once you've post-processed that, all your CNC is going to run is this drill function, and it's just going to drill the holes. After it's drilled the holes, do not change the 0 point of your CNC. I repeat, do not change that. Don't mess with it, because the 0 point needs to stay the exact same. What you're going to do now is that now that the holes have been drilled out of your stock, you're going to take some bolts and you're going to bolt down that entire sheet of 1/4 inch thick metal into the wood, the MDF that's underneath it. So bolt it down into the MDF. Once it's bolted down, you can see how you won't need tabs anymore, right? The whole plate shape, the whole thing has been bolted down to the CNC bed, so the tabs don't need to hold it in place, the bolt holes do. Alright, so now that our drill function has been completed, we can repeat all of our other functions. Just a few numbers have been tweaked. This time we don't need tabs, and then we do need to allow for some clearance, because when we put those bolts in, the bolt heads are going to be sticking out. So we need to tell the CNC that it needs to raise up higher to make sure it doesn't hit one of those bolt heads and just break the bit. So let's get rid of the drill function. Say we've already post-processed it. Now let's do the contours, or sorry, the pockets. So pockets are anything that you want clean edges for. So let's say I want this. My bearing holds, I want clean edges. Well, actually, now that I do think about it, since we are bolting it down to the bed, it is going to be okay to just do everything as pockets. It's going to take longer, yes, but bolting it down just removes... So if we did contours, we would need tabs all in this area, right, to keep this metal piece from flying out. And there's no way for us to bolt down the little metal piece, unlike we can bolt down this whole plate. So what we really can do is just do contours for everything. So we can go ahead and do that, actually. Just contours for everything. Sorry, I'm so sorry. Pockets for everything. Pockets. So this is going to clean everything up really nicely. If you make a mistake like I just did, just hold shift and click that mistake you made. Alright, I'm just going to keep going on, clicking all of these holes. Alright, and we should be done. Alright, let's mess with the numbers a little bit. Our tool is going to be the 3/16 tooling again. I'm going to slow it down to 12. Alright. We don't need to mess with any of these, but we do need to change this. So just like before, our bottom height is going to be stock bottom, but now these heights are what we're going to mess with. So as you can see here, our clearance height is this line. Retract line is kind of not, you can't see it, but the retract line is just describing how far the bit's going to retract. And this is your feed height. I honestly don't know what that means. And this is just the top height of the stock. So what we're going to do, just to keep things safe, is change the retract height. Instead of 0.2, let's do like 0.5. So as you can see, it brings that brown line up way above the stock. That is a bit excessive, so I'm going to turn that down to 0.4. Alright. And then I'll change the feed height to 0.42. I haven't messed around with what leaving the feed height is as it is, and I don't want to. So I'm just going to change that to 0.4, that to 0.4, and that is how we've done it. And it keeps it safe. If we do get the opportunity to test out messing with these numbers, seeing how both heights differ, we'd love to do that, but right now we're just going to keep things safe. Over here, get rid of stock to leave. Definitely be doing multiple depths, and the number to know is 0.015. Just have to memorize that. The last thing we need to change is the ramp. So right now the minimum ramp diameter is this. It is going to be 5 zeros, so 1, 2, 3, 4, 5, 3, 1, 2, 5. Just click OK. Just let that load. Alright, it's loaded. Everything looks good. If I hover over it, it gives me a bunch of nice pats. That looks great. Now, one thing I want to do is run through a simulation. Make sure everything's good. I'm going to add the stock in. That's just nice to have to see what's getting cut. And let's run the simulation. Alright, looks like our stock did not show up. Let's close this and reopen the simulation. Maybe. Alright, I honestly do not know why it's not showing up right now. But as you can see, your statistics show these two plates are going to take 5 hours, which is extremely more than machining with tabs. The only benefit this gives you is just having like cleaner cuts. Like you have cleaner edges to work with. And honestly, that's not that big of a benefit, but in some situations you do need it for like smaller parts that need to be very precision machined. That is necessary, but for gearbox plates, we don't need to do that. We're okay with just filing it down with hand, all the tabs, and then powder coating the whole plate as is. In some situations, this process is applicable, but for now, I just made this video to show you guys how to do it. Alright, let's speed this up. Make sure it's covering all the pockets. So as you can see, thankfully I ran the simulation because I can see that I missed one big pocket here, so I'm going to close this, go back to my 2D pocket, go to my selections. Right here, I'm just going to select that. Hit OK. Alright, everything should be good. Now all I have to do is post-process it, upload it into the USB, and run it on the CNC. And that's all there is you have to do differently than camming with tabs. Alright, thank you.